Hello and welcome. In this video lecture, we are going to get started to work with the timing methods and how to control the frequency of the inputs and outputs. Let's get started. Now that we have mastered the process, let's open a new file in Arduino IDE and import our software serial and start with beginning the software serial in the setup method and then do some interesting stuff inside the loop method. Start by typing #include software serial.h, then inside the setup method serial.begin 9600, and let's save the file, Ctrl S, wait for time. Now inside the loop method, let's type serial.println loop and then delay of 2 seconds, and that's it. Let's upload the code to the Arduino Uno board. Now it's done uploading. Let's open the serial monitor. Now we can see the frequency is a little bit slower. Let's make it a little bit more interesting by increasing the frequency. Let's make it 10 seconds so that we can feel the difference and upload. It's done uploading. It's slightly slower. Let's make it even more interesting by using another method from the timing methods of Arduino IDE. So instead of just printing loop, let's modify that, make it print loop colon and then serial.print micros. So that will give us the timing in microseconds on the internal clock or the oscillator of the Arduino board. Let's upload that. Done uploading. Let's open the serial monitor so we can see I've forgotten to print on a new line. Let's clear the output, get back to the code, make sure that we are printing on new line. Print line, upload, done uploading. Now we can see we are getting the time in microseconds for every loop. Now we can see the time is incrementally increasing throughout the loops. This is very useful when we are working with sensors and different outputs and inputs, and also when reporting and logging different inputs and different actions to another server. This example that we work with in a future section. But now we have known how to get the time in microseconds. Let's make that even more interesting and get the time in milliseconds. Let's get back to the code, and instead of micros, let's say millis, and that's it. Let's upload. It's uploading. Serial monitor. Now we're getting the time in milliseconds. So a question that might pop up in your mind at the moment, according to time zones, Greenwich and Universal Time Zone, etc. No, it isn't. This is actually the number of milliseconds passed since the Arduino board began running the current program. So it's reported on their documentation that this number will overflow after 50 days. That means every 50 days, the number will be reset back to 0. That's if you leave your Arduino running for 50 days. That's you have deployed some hardware product that's built around Arduino. You should take that into consideration. So before we conclude this video, let's introduce one more method to control the time and the frequency in Arduino. Let's get back to coding, and instead of delay, we say delay microseconds. Let's increase the number a little bit, make it 1000, or be 1 millisecond, and let's upload the code. Now that is uploaded, let's see the serial monitor. So the delay is not very apparent. That's 1 millisecond of delay, but you know how to control it, fine tune it to the test you feel more comfortable with. But usually we will control that according to the application, and in following sections you will see why these functions are really helpful, why you need to delay for a microsecond, why you need to delay for a millisecond, and why somewhere in between. This will come handy when we introduce real applications in future sections. See you in next videos, and thank you.